G'day comrade subscribers. Something a bit different today, if you don't mind. So this is the Sirius clone, Spectrum clone, and we need to basically put in a new tape-in circuit. So tape data comes in and is fed to the BMC, which is like the gate array or ULA. So this is one design. This is from a Belarusian computer called the Raton 9003. Uses the same BMK, so I thought try the same circuit. And so you can see here, tape in, basically capacitor, consumer resistors, and then we've got a hex inverter chip. So one chip, couple of passives, and that's it. So I thought it might be interesting to do a video on doing the design in KiCad, generating a PCB, and then sending it off for fabbing. Although I probably won't do the fabbing part. And this is just basically designing and generating the Gerber files, or Gerber, or Gerber, or no doubt I'll get corrected because I've said it wrong. But yeah, a few caveats. Bear in mind, I'm not a KiCad super user. I'm not a circuit design guru. I'm simply a hobbyist who sometimes likes to or wants to design simple circuits, simple PCBs for my hobby. So this is just how I do it. This is how I've kind of learnt myself how to do it. It's not necessarily the right way or the best way. It works for me. I think you'll see, you know, it takes about an hour. So that's like talking and everything as well. So something simple like this, I can whip up a PCB ready for fabrication in about an hour. So just something simple, you know, I don't want to spend hours and hours and hours on something, you know, because especially if it's not going to make me any money. So that's the idea. So I just want to kind of reproduce, because I could, basically the circuit here doesn't match this. So even if I just put the chip in here, I'm going to have to cut tracks and all sorts of things. So I thought I could just do a little PCB, kind of like actually what I've done before. Let me just grab it. So this is the UMPKR, so a homebrew 86 RK base machine, the venerable 8080. So what I did here is, because it came with a UHF modulator output, I wanted to get just composite baseband. So what I've done here is I've just taken Sergey's design actually from his homebrew 86 RK. What's it called? Radio 86 RK. And just designed a little PCB that I could, you know, just insert here and then just send the signals across, and then I get the output. So that's the kind of idea. Is I've got something I want to, rather than try and, you know, making, you know, with a breadboard and things like that, just whip something up like this quickly. That's the idea. Hopefully you get some value out of it. Hopefully you guys can give me some tips on how I can improve. Yeah, always happy for feedback. Just don't be a dick about it. That's the general rule. Just, you know, constructive feedback's always welcome. Everyone was a beginner at some stage, so yeah. Anyway, enough talking. Let's give it a go. Okay, let's get started. So I've knocked off work early Friday afternoon, so I've got a little bit of extra time. So first of all, we want to just create a new project, and we'll call it tape to data. Create a new folder for the project. Now we've got our PCB in Schematic. Let's open our schematic. First thing I'll do is I'll just make some adjustments to the sheet. So don't need A4, so I'll do A5. Put in today's date. I like to write it out so nobody gets confused. I hate all these American ads, and it has the date in the American format, assuming everyone in the world uses American format. And it says coming 3/5/2025. So is that the 3rd of May or is it coming 5th of March? It just confuses people. So I just like to do this. Anyway, title, tape to data, I don't know, board or something. And I'll worry about all this later, you know, put my YouTube channel or something. Right, so what do we need? We've got one logic chip, hex inverter, CMOS version. So it's a K561LN2 is the original part, Soviet part, but we'll be using a 4069 CMOS hex inverter. So we need one of those and some resistors, a couple of capacitors, and some way of getting signal in, signal out, and also power. So let's do the inverter first. So go over to our parts. So I'm using KiCad 9. I've just upgraded last night. Lost everything, of course. Have to find everything. Right, so we've got two options here. We've got this symbol. So we've got our inverter symbol, or we've got this IEEE symbols. So I think we'll just do that one there. And it'll be unit by unit. So what we'll have is, rather than having a whole chip, we'll have each individual gate. So as you can see here, as I zoom in, U1A. So let's just plop these down, like so. So we've got 6 in total, and then we've got the power supply. So we'll just stick that up there. Now what else do we need? Okay, some way of getting the signal in. So I'll use a like a header, pin headers. So I think, is it a generic connector? Here we go, connector. So we'll go con 01 by, so we need 4 pins. We need tape in, data out, 5 volts and ground. So we'll have just a generic, so we've got a couple options here as well. We've got pin sockets, so we'll just go for this one here, I think. So we'll just stick that up there. And now our passive components. So we need an R. How many of those? Let's just stick one in. And we need a C. Unpolarized capacitor. So we'll stick that one there. So C, so this value here, this C is the actual value. So we want 0.1 microfarad, which is 100 nanofarads. So we actually want 2 of those. So we'll just make a copy. All right, so we've got one on the actual circuit, and then the other one I'm going to use for decoupling. So give the chip a little extra power. Now for the resistors, so we've got 300K and a 6.8K. So I like to put the symbol. I know that's not the stylish way of doing it, but I like doing it. So we've got 3 of those and a 6.8. I'm not too worried about, because this is quite a simple circuit. I don't really care about the component numbering. I won't even have it on the PCB. I'd rather have the part values on the PCB. Right, so let's go up to the connector here. So for that, so I can either basically draw wires down all over the place, or I can use these labels. So let's see, so say tape in, and it'll be facing that way, like so. So we've got a tape in, and then let's put the power. So let's have ground plus 5 volts, and say data out, like that. Okay, so let's sort the power out for the chip. So VDD, so I think that's 5 volts, isn't it? So let's put plus 5 volts there, and here let's put ground. Okay, just to rotate that around like so. So the chip's powered, and now decoupling capacitor. So let's move that over there. Let's do that one there. Rotate it. Alright, let's rotate it like that. Then let's just move that down there. Of course, I could also put up the top there. And let's put some wires to connect it up. There we go. Power's sorted. Now, according to this schematic, we've got tape in coming into the capacitor. So let's move this over there, rotate that like that. Let's stick a label on there. So was it tape in? All right. So signal comes in, and move it a little bit. Okay, into the capacitor. Then we've got 100K. So let's just move these out of the way. Stick them there. So we've got 100K capacitor. Rotate that. So I can either leave it there, or you can just attach it and then drag it. And then we go into the first inverter gate. So they go into gate 3. So that'll be the C, pins 5 and 6. So that's how they do it. We'll just do the same. All right. And then we've got a 100K kind of bypass sort of thing. Rotate that around. Like so. Okay, stick that there. Add some wires. Okay, and then we've got 3 gates in series. So we've got gate A, pins 1 and 2. Then we've got gate B, 3 and 4. And then we've got gate, what's that, E, 11 and 10. Okay. And then we have these two in parallel. So I just stick that one down there. Stick that one up here. Let's just move this out of the way. Down here. Sorry, I'm using a trackpad, so maybe I should be using a mouse instead. Okay. And then we've got that connected to data out. Okay, just rotate that around like so. And should have another resistor. Another resistor there, so that's all right, that's all right. Let's just select all of that. Just move this along. Delete that wire. And then stick this in. Like so. Okay. And then select all that, move that back there. Done. All right, and then we've just got this one pulling up, I guess, to 5 volts. So pulling it high, I guess, maybe. And add another label, plus 5 volts. There, let's just move it up a little bit. Okay, and that's basically it. That's the circuit. Okay, so now let's just save it, Command S. So before we can create the PCB, we've got to assign footprints. All right, so let's stick 4069. So that's a dip. That's a package. DIP package. And it's a 14 pin. Let's get that out of the way. That's a 14 pin, so DIP. All right, so DIP -14 7.62 mil. I don't think we need anything else. It's not a wide one. It's not surface mount. I don't know what side brazed means. But alright, so that's that one done. We've got a connector, so I think there should be connectors or generic. Here we go, connector. Oh, here we go, connector pin header 2.54. So we want 1 by 1x04, there we go. And we can either have either vertical or horizontal, so I think maybe right angle. So, because we could have vertical, which will save space on the PCB, but I don't know how much space we've got on the board to the keyboard. So let's just do horizontal. Worst case, you don't even need a pin header, you can just connect the wires directly in. So let's do that. And now let's do our passives. So for the capacitors, I want to reuse the Soviet parts. So I measured them, they've got a pitch of 8 mil. So what was it? Capacitor through hole. So it's kind of ceramic, you could class it as ceramic disc. Alright, so C disc, let's do that, C disc, well that narrows it down. Right, so pitch, 7.5 is probably the closest. Depth 7.5, that's, I don't think you need something. So the pitch is 7.5, depth, that's how thick or something it is, isn't it? I wonder if I can I do space P7? Oh, very good, I can do that, excellent. Alright, so these are all the ones, because I don't think there was an 8, no. Alright, so 7.5 is the closest. So, well, we've got 7.5, so that's probably the best I'm going to be able to do, I guess. Let's see what it does anyway. And now the resistors. So go down to, let's clear the filter. Let's go down to resistor through hole. Resistor through hole. Axial, R axial, that's all right, R axial. Well, that helps. So we'll do vertical. Okay. So I think they're generally, I think they're 6.3 mil. So I think maybe 5.08 if we're going to do them vertically. Definitely not that big, so I think that generally they're 6.3. I thought 6.3, maybe that one. Maybe, oh, so didn't select it. Maybe, what was it? Length 6.3, pitch 5.08. All right. Okay, and yep, we've got to save again. Okay, so that should be ready. So now let's update PCB from Schematic. Okay, update PCB. There's everything. So okay, we need to just change the page setting as well. Let's change it to A5. And today's date. Oh, capital, sorry. Anyway. So there we go. Oh, wow. That's pretty thick capacitor. They're not that thick. It's just the legs are wide. Yeah. All right. Well, I can update those. That's not a problem. Let's all right. Let's move some things around. Now, I don't like all these. Like, for example, all these part names. I don't need them. I much prefer to have the part, not the part identifiers, like the part values on here. So for example, the chip here, so we get rid of U1, we don't care about that. And for that one there, we don't want that to be visible either. Now for this actual here, so the main layers that I normally worry about is we've got our top copper, our bottom copper, we've got our top silk screen, our bottom silk screen, so that what you can actually see printed on it, and edge cuts, which is the actual sides of the PCB. So they're the ones I mainly worry about. So for example, if I want this, what I like to do with this 4069 is rotate it and then just stick it in the middle here. So it's okay, that's where I put the 4069. But it's the F-Fab, which I don't think you get to see. So for ease, I just move it to the silk screen. So now it'll say 4069 on the silk screen. Similar with this, okay, so for this here, I don't care about that. You can probably just even delete. Can you just delete it? Yeah, you can just delete that. I don't really care about that in this case as well. For this one here, I probably want to do some text just to indicate what pins are what. Please remember to do that. If you've got a 6-way header on there and you don't say what the pins are, it just makes things easier. All right. Yeah, these capacitors are too thick. The pitch is enough, right? So the capacitors will fit in nicely, but they're just too thick. I don't know if I can. I could open footprint editor. I could change. Let's get rid of, like, for example, I don't care about the reference. Don't care about that. And this, for example, can I move it here, or I'll worry about it later? I'll change it here. Put it on the silk screen. Now to actually edit it. Have I done? I think I have done that in. So I can do some editing. I think I have done simple stuff before. whether it's worth doing it, or if I just choose some other. So you can do this and then you can update it. So like I could make it thinner. I'm not going to muck around with this now. Discard changes. Maybe for another project, if I do a video like this again, maybe we'll look at editing that. So what I might do is I might change the. Let's just save it for a start. Let's switch back to the schematic editor. Actually, one other thing I need to do is a mounting hole. So I don't want the board floating around. And I don't want to like attach it with double-sided tape. I want to be able to put a screw and like drill a hole in the motherboard and then secure it. So I should add a mounting hole as well without connection. And just plunk that wherever. So let's assign footprints again. Let's do the mounting hole before I forget. What's that under? Mounting hole. Right, so I want an M3. M3 stuff. 3.2mm pad. DIN, ISO, I don't know what the difference between all these are, so I'm just going to go for that basic one there. Now for these capacitors, what should we choose instead? What should we choose instead? So C disk. See, they're quite small. All right, let's won't worry about it for now. This is just a quick, might not even work. So let's just go with 5mm pitch. 5mm pitch, depth 4.3. I think that's probably about right. All right, let's just update. Let's update those two. Okay. Save again. All right. Update. In KiCad 8 for the Mac, this didn't work. Yeah, this didn't work. If you tried to change or add something, it wouldn't appear. You'd have to quit KiCad to come back into it. But it looks like it's working now in KiCad 9. That's good. All right, so as you can see here, so this is kind of what I wanted. So I need something like this, but 8mm wide. Yeah, I might do that. I might see if I can edit that. I might do. I'll see. Let's just make the PCB, and I might add an extra section at the end if I modify this. Anyway, all right. So let's do some basic layout. You can see the wires here. That's all the general connections. So one of these capacitors is decoupling for the IC. Which I don't think is that one. I think it's this C2, is it? Oh, okay, it must be C1 then. Where is it? Ground and 5 volts, yeah. So what I'm just trying to do here is just trying to, minimize the length. So you can see here it's saying, okay, the closest ground connection is up there, so I'm going to link to that. I guess it doesn't really matter. So if I just stick it, let's just stick it there for now. And again, I don't care about these. All right. There we go, got that one selected. And I just want to move this to the silk screen. If I could probably make the text a little bit smaller, and I could even fit it in there. So, or the other thing is, like, especially if all the parts are the same, you could just get rid of all of that and just say all capacitors 100 nanofarads, all resistors 100k, and that way it saves even more space with this without having to have this text. So, but yeah, let me just go through. I'm going to go through. I'll get rid of all the stuff I don't want on there, and then it'll be a bit clearer. How we lay it all out. Right, I've just about got it done. So just a note here. So here you've got, when you double click on it, it says footprint text or reference field text. So there's actually two bits of text on top of each other. So if I choose that one, well, if I do that one and then go properties, no visible, you can see, oh, it's still there. That's because there's actually two. So when it showed up, you can actually do select all. So I could have just gone select all and then just delete, and would have deleted both of them. So just a note. But there we go, front silk screen. And I think that's pretty much it. So what you see is pretty much what will be printed on the PCB. So now I just need to organise things around to try and minimise these paths. So we'll start doing that in a minute. Okay, let's get back into it. So what I want to try and do now is kind of minimise, like we've got these crossed over there. Just try and minimise the tracks. So mounting hole. Oh, that's right. I want to put text in here as well, don't I? Okay, let's just stick that up there. All right, so we've got front silk screen, some text. So we want to put in tape in ground plus 5 volts and data out on the front silk screen. All right, doesn't really line up, so let's also change it so it's right formatted. And let's go 1.5 width, 1.5 height. Okay. That matches up quite nicely, doesn't it? So I could probably put it over here as well, but then it's going to be covered, or I could even put it on the bottom. You know, rather than, if I wanted to save space up here, I could maybe put it on the underneath of the board. There's some space there. Let's just stick that in here for now. Okay. Let's stick that up there then. All right, what's the next one? Well, let's maybe line that up then. Maybe. And there are tools where you can, I think, where is it? Positioning. No, align to. Oh, I always get horizontal and vertical center. Vertical center. Okay, I think that did it. All right, now what's going on here? Okay. So you could always, also, if you wanted to, you could also move the text up there, but I think we're okay. Alright, what about if we rotate that around? That's a little bit better. Whoops. Like so, and then this one at the end. So that, okay, so that data out, so that kind of makes sense to have it like that, I guess. So you could do that like that. Depending on how much space. So see, we've got kind of got space, haven't we? So we could do it like that. So I wonder if I can do this. And then positioning tools, oh no, align to a horizontal center, like that. Okay, and then just move them out a bit like that. There we go. Oh, something like that, maybe. Okay, now we need to do the outside of the board, so go to edge cuts, like that, and do a oblong, rectangle, something like that. Okay, and I hate sharp corners on PCBs. So what I like to do here is, whoops, sorry, Control click and then go to shape modification, fillet lines, and do maybe 1.5 millimeters. How's that? Now we've got nice round edges on our board. Okay. So you can see it could actually move all of this stuff Could actually center it a bit more. Couldn't we? We could actually move it over a bit. Like that. Okay, save it. Now, I use something called Freerouting. So to get that, switch to the project manager. There's on the main project manager here, there's this plugin and content manager. And you've got plugins. So there's probably others, but this is just the one I started using. Freerouting. And then you just go install, and then you apply pending changes, and it installs it. So there's libraries and PCBWAY. I've got some fabrication plugins, so just one click apparently you can. I haven't tried it yet, so we might give that a try at some stage. Because I don't really have a BOM, so if you upload a BOM as well, it allows them to actually put the components on the board if you want them to. Color themes, okay. And these other libraries, key switch library, oh, that'll come in handy. Generic symbol library, so there's some other library. Anyway, so free routing. So I've already got that installed, so let's go back to the PCB editor. And what we do is make sure we've saved it, go to Tools, Free Routing. Okay. Starts up, starts shortly, start now. Yes, oh, it's really annoying me. I already sponsor you. I don't need to show me user settings all the time. Right, and this is the result. So red is the top copper layer, and blue is the underneath copper layer. So we've got, because it's a 2-layer board, looks pretty good. If you wanted to add, like, say, a ground plane, then we can go to, say, ground plane on the bottom side. So we've got B copper, and then we want to create a fill zone. So let's just go yep, and then we choose, say, ground. So say we could have a 5-volt one on the top. I don't know, but normally I just do ground. So ground plane underneath, and then we just kind of draw a square. I do it just outside the board to make sure that it kind of gets everything. And there we go. Okay, so now what we can do, so what have we got here? So we've got ground. So we've got ground running down to here, and then going down to here. So if we now go fill all zones, and now we've got a ground plane on the bottom. We obviously still have this, don't really need that connection anymore, do we? So I wonder what would happen if we, all right, if we keep the ground plane how it is. This is not something I've tried before, I'm just trying it now. So global deletion. So if you want to delete all the tracks and try again, you go global deletion, tracks and vias. Okay. We can see it's left gaps where the, we've still got the ground plane connections, but it's left gaps on the underside where there were non-ground tracks. So what happens if we run the free router again? Start now. Yes, go away. Cool. All right, so yeah, it's removed those additional traces for the ground plane. What do you think? So should I keep the ground plane or not? The only problem is that we've got the mounting hole there. All right, so we can leave it like this. And well, let's have a look at, save it of course. Let's have a look at what it looks like 3D. There we go. So because we use generic parts, it's already got the 3D symbols included, so we can display what it looks like. If you've got some exotic part or some part that's not in the library or has a 3D representation, then you can usually download them. So that's the underneath. So here I could, for example, put you know, designed by Brett, based on Raton schematic or something. But yeah, so if you've got some weird part, you could usually, like DigiKey, I think, oh no, it's not just Mouser or Element 14, mainly Mouser I think I use. But you can download the EDA libraries for a specific part and a 3D representation as well. And if they don't have one, you can request it. So, but yeah, so that's basically what it should look like. I think I've made good use of the space. It's not too big. I probably could, sorry, I'm just trying to, probably could move everything over a little bit more to the left, and then we could probably trim a little bit off the side of the board here. I'd have to redo everything though, because it's no longer, yeah, it's all separate lines now. It's not a square. But that's the basic idea anyway. Okay, so let me just let's get out of this. Let's just add a little bit of text, so we can flip the board over. Flip the board view. So now we're looking from the underneath, and we can get rid of, say, if there's all this text on the top, the front silk screen. So get rid of that. And so we've got some space here. So we want to write on the, so let's select the back or the bottom silk screen, do some text, and you can go designed by board by Brett Hallen, Feb 2025, based on the Raton 9003 schematic, and then I don't know, put my YouTube address or something. Okay, back silk screen. Okay, and just rotate it around and say stick it there, something like that. And then if we go and look at the 3D viewer again, okay, ta-da! So there we go. That's basically it. All right. And obviously, like for example, with this here, we could actually move this so the pins were hanging off the edge of the board. It would just mean that the that, you know, obviously that it cuts off this white under silkscreen text here, but it doesn't matter. So if you wanted to save even more space, yeah, that's the general idea. So finally, what we want to do is let's just flip the board view back. I don't know if this is just something I'm doing quickly, so I don't know if I'll actually submit this to PCBWAY or not. Okay, now to generate the Gerber files, go to Fabrication Outputs, and I just, whatever, just default. Oh, I should probably run Design Rule Checker as well. That's pretty simple, so it usually shouldn't be a problem. What was it? Inspect, Design Rules Checker, run DRC. And yeah, all seems happy. All right, yeah, seems okay. Right, fabrication outputs. So just plot and then generate dual files. Gerber X2, generate map. I just generate everything. Close. That way everything's there. And so you can see this is our project directory. So you can see I've got our schematic file, project file. That's some sort of, that's our PCB file. And then everything here are the Gerbers. So just select all the relevant files. That's them. And put them into a zip file like so. And then tape to data Gerbers. And then that's basically the file that you upload to PCBWAY. So that's basically it, done. So I'll 3D viewer, do something like this, take a screenshot, and I'll probably put that as a thumbnail or something. But that's how you design a very simple board. Yeah, hopefully that was of some help or some interest. Yeah, obviously if there's something I can do to improve, let me know. Don't be a dick about it. I don't profess to be an expert. I'm a hobbyist that just likes to do simple things for my little hobby. And I bumble through. Bonus credit. Let's see if we can modify the footprint to allow for the Soviet kind of 8mm pitch. So what do I want to choose? I want to find a distance. There was a measurement. There was a measurement. Tools. So there was a measuring. Was it this one here? I should have clicked. What does it say? Place a footprint anchor. No, it wasn't footprint anchor. Interactive delete tool. Draw orthogonal. Oh, could it be the one that's a ruler? A rule. Okay. So at the moment, there to there is 5mm. So we want that to be 8mm. So we need that to be kind of out there. Okay. So that means we want to kind of, can I kind of lock that? I need it to be full width crosshairs. No, I need it to, I need this, don't I? Through to origin, no. I need it to snap. Grid overrides, no. I want it to snap. Well, actually, I think there are tools which allow you to positioning tools, move exactly, move with reference. Yeah, okay, so we want to move 8mm on there. Let's see what this does. Oh, okay, so it moves both of them. All right, okay. All right, so let's move that back to where it was. Okay, so we want to move this. Positioning tools, move exactly. We want it to move another 3mm. Okay, so if we get our rule out again, that should be 8mm now. All right, 8mm. So now, what we want to do is we want to move that, basically move everything 3mm. What do you reckon? So if we move those two, move. How come it looks different? Why can't you snap? Did I switch something off? Did I switch something off? There's that, but it wasn't snapping before. All right, let's just do one at a time. Positioning tool, move exactly 3 mils. Ta-da! And same for this one. Positioning tool, move exactly 3 mils. Right, okay. And then we just need to extend these, don't we? This just needs to extend out to there. Okay, I was hoping it would connect directly, but alright. That one snapped. Why didn't this one snap? That's a bit weird, isn't it? Oh, that snapped there. Okay, and same with that one. Okay, that snapped. That one snapped, and then can we just segment? I don't know what you're talking about. All right. Can we change properties? Shape modification? No. What about if, okay, what if, just change properties, we just change the length. Start point, alright, so start point is there, end point, so we just want it to be another 3 mil. So if we make it -4, probably could have done that with, what's that dot there? Hello, what's this? What's that dot? What's that dot for? Oh, okay. Well, let's move that then as well. Positioning tool, move exactly 3 mils. All right. So we've got to move that. All right. So this one, properties, make it 3 mils longer. And just move this one. Positioning tool, move exactly 3 mils. So that should hopefully, we could even fit that in there. So that should hopefully be, all right, editing C1. I've got to do the same again. I should have. All right, anyway, so let's, saving will update the board only, that's fine. So let's save that. All right, let's edit, unfill all zones, edit, global deletions. All right, so now this should be, not text. That should be our Soviet capacitor. Why aren't we seeing, oh, there they all are. Now, if only, yeah, I wonder if I should go back to Window, Footprint Editor. I wonder if I can save this as, yeah. Anyway, so that's kind of how you do it. That's just, obviously this is temporary, just modifying that. If I'd had any intelligence, I would have created a new, I would have edited or copied it in the global library or whatever. But yeah, okay, something extra. All right, bye for now.